Assalamualaikum and hi Dr. Hamdi. My name is Assalamualaikum and hi Dr. Hamdi. My name is Amshah. In this video, we will present to you about the AC generator. There are 4 parts which are the introduction, working principle, application and summary in this video. For the introduction part, which will be presented by Jivan, he will present what is AC generator, the theory of physics behind the AC generator and the origin of the AC generator. Next, for the working principle part, which will be presented by Shukri, he will explain the working principle and the equation of induced EMF in an AC generator. For the application part, Suvita will explain the application that use an AC generator. And lastly, Fayad will summarize everything about the AC generator. Without further ado, let's move to the introduction part.
Hello. A simple AC generator consists of a coil of wire rotating in a magnetic field. Electromagnetic induction can create a potential difference. This potential difference causes a current, and the effect is used in electric generation. Without the invention of AC generator and its development over the past century or so, the world would be a very dark place indeed. Generators producing alternating current powers our light, our heating system, our cooling system and our computers. Originally invented by an accident, AC generators were once deemed worthless and unusable for many years before they finally became the indispensable machines they are today. The history of AC generators is intertwined with the history of dynamos and electricity. The electric generator has its origin in the work of Michael Faraday and Joseph Henry, who discovered electromagnetic induction. The first AC generator was created accidentally by Hippolyte Pixii while he was inventing the first dynamo in 1832, which delivered pulses of DC electricity. Until the late 1880s, early use of electricity was limited to direct current in the US. Thomas Edison had invested heavily in DC technology. However, DC power began to run into problems where more people wanted electricity in their houses. So DC current could not easily be converted to different voltages, so power stations needed to be within a few city blocks of each customer. This soon changed thanks in large for the work of Nikola Tesla. In the late 19th century, Nikola Tesla, backed by George Westinghouse, had shown that alternating current can be converted from one voltage to another using a transformer. So power can be sent over long distances and using a high voltage and then throttled down to a lower voltage to service customers.
Now, I will talk about the working principle of the AC generator. The AC generator consists of a wire loop that rotates in a magnetic field by some external means. An amount of energy is required to rotate the loop. As the loop rotates, the magnetic flux through it changes with time, thus producing the electromotive force and the current in the external circuit. The ends of the loops are connected to the slip rings that rotates with the loop. Then, by using the EMF equation, we can derive the electromotive force generated in the rotating loop. Based on the figure, we can see that the wire loop is rotating clockwise with the uniform magnetic field directed to the right. In this case, the magnetic force on the charge in wire AB and CD is not along the length of the wire because the force of the electron is perpendicular to the wire. Thus, an EMF only generated in BC and AD. At the same time, the wire BC has velocity V at angle theta and the magnetic field B. The generated EMF is equal to BLV, where B is the magnetic field, L is the length of the wire, and the V is the velocity component perpendicular to the wire. The same magnitude of EMS is generated in the wire DA. Then, we can express the motion mathematically as epsilon equal to 2BLV equal to 2BLV sin theta. If the loops rotate with the constant angular speed of V, then we can use the relation of theta equal to omega t and the V equal to r omega equal to 2 over A, where A is the length of the sides AB and CD. Then, if a coil has n number of turns, then the EMF is n times larger because each turn has the same EMF. Then, because the area of the loop is A equal to LA, then the total EMF is epsilon equal to NBA omega sin omega t.
AC generators are used widely in many different applications. All the power stations use AC generators to produce alternating current. These devices can be categorized based on the different applications of AC generators. Some applications of AC generators are marine alternators, brushless alternators, diesel electric locomotive alternators, automotive alternators, and radio alternators. Marine alternators are the type that are used for generating powers in marine applications, as the largest engines use an extra large case or multiple alternators to supply adequate power. Brushless alternators are the types that is the main source of power in electrical power plants. Diesel electric locomotive alternators is where the locomotives need electrical and mechanical power simultaneously, and the source of power is AC generators that is usually used in ignitions of diesel fuel in the fuel tank of vehicles. Automotive alternators uses modern automobiles generators for satisfying electric power. All the electric power in the vehicles and charging battery is generated in AC generators. Radio alternators are the types that are used for transmission of radio frequency in low bands and used as the radio transmitter. AC generators produce an electric current in different power stations. Hydro and wind turbines, power plants, and other energy harvesting system uses AC generators to produce alternating current for cities and facilities. AC is appropriate for the transmission of electrical energy in long distance, and as a result, AC generators are the essential part of each power source.
In conclusion, thanks to Nikola Tesla, we were able to live a life with a reliable and constant supply of electrical energy to homes, businesses, and industries, which we took for granted. AC generator has had a significant impact on society and the environment. It powers many devices which have become part of modern life. It has reduced the amount of laborious housework and has made many tasks easier. People have more leisure time and a higher standard of living due to growing technologies. The AC generator has had a positive impact on modern day society, although it does have its drawbacks, especially towards the environment, like the sources of energy used to power the generators, for example fossil fuels, that causes an increased amount of carbon dioxide in the air, causing air pollution, thermal pollution, and contributing to the enhanced greenhouse effect. Despite that, we are moving towards green energy as we use hydroelectric and air turbines, which reduces the pollution, yet still maintaining to supply the energy demand. It is also important to learn this technology that we took for granted, as it has been crucial to us since the invention of it, that contributes our growing technology ever since. There is a lot of impactful applications of AC generators to our modern world. Thus, AC generator is a wonderful yet simple invention that revolutionizes our way of living and how electricity is contained and delivered, with more to come in the future. As technology progresses, the limitations of AC generators will be overcome in the future.
Finally, we already reached the end of this video. Let me recap back what my friends present just now. We already learned that an AC generator is a device that produces a potential difference. Thanks to Michael Faraday, Joseph Henry, Hippolyte Pixii, Thomas Edison, and Nikola Tesla for their contribution that make our life easier with the creation of AC generators. We'll also learn the working principle behind the AC generator and the equation of induced EMF for AC generator, which is epsilon equal to NBE omega sine omega t, where N is the number of turns, B is the magnetic field, and A is an area of the loop. Various applications use AC generators in this modern world, such as marine alternators, brushless alternators, diesel electric locomotive alternators, automotive alternators, and radio alternators. That's all from us. Thank you.